hands-on math. This video demonstrates how to solve some basic trigonometric equations and find all the solutions on the unit circle. So we're going to solve the equations algebraically and use the calculator only to find inverse function values and look for all the solutions on the unit circle from 0 to 360 degrees. So to get started, the first equation, cosine x equals 0.53. So we can apply inverse cosine, so x equals cosine inverse of 0.53. The calculator can give us a value for that. When using a graphing calculator, I want to make sure I'm in degree mode rather than radian mode because I'm looking for solutions in terms of degrees. So we are in degree mode, so that's good. And then inverse cosine of 0.53 gives us one of our solutions. So that's pretty close to 58 degrees. So let's say one of our solutions is 58 degrees. So we can think of that as a point on the unit circle. 0 to 360 degrees represents a full trip around the unit circle, and one of our solutions is 58 degrees. That corresponds, what we just found is that corresponds to an x-coordinate on the unit circle of 0.53. Right? That's what the cosine function represents. So there's a second point on the unit circle that offers us a solution, and it corresponds, most simply, it corresponds to negative 58 degrees. Right? So that symmetric solution is going to come from negative 58 degrees for cosine. That's outside of our range. We're interested in solutions between 0 and 360. So to work with this other solution, I can add 360 to that, and we get a second solution, x equals 302 degrees. So the two solutions to that first equation are 58 degrees and 302 degrees. So the two solutions on the interval from 0 to 360. It's nice to have ways to check our work here, and the calculator offers that. So we can take the cosine of 58 and see that we get, essentially we get 0.53 with some, rounding error. And if I take cosine of 302, I get the same thing. So I know that I found that, that appropriate symmetric solution. For sine of x, we can work through and solve the problem in a similar way. I'm interested in finding the values for x when sine equals negative 0.18. So we can apply the inverse sine function to that ratio. So inverse sine of negative 0.81 will give us a negative value for our angle. So rounding to the nearest tenth, we end up with x equals negative 54.1. Well, that's a point on the unit circle as well, down here at negative 54. So that's the point where the y-coordinate is negative 0.81. That's not quite the angle that we'd like. We'd like angles between 0 and 360. So to adjust and get an angle that works better for us, that works within that range, what we can do is add 360 to that value. So the angle that we're really looking for is 305.9 degrees. Right, so that's this point on the unit circle, 305.9. The other solution is in the third quadrant, right, that has the same y value. And so I like to say that these solutions for sine, they're going to come from supplementary angles. That word is a little bit awkward here because we have an angle that's bigger than 180 degrees, so it doesn't really have a supplement, but we can find the solution by doing what we would do to find a supplement. We could subtract that angle measure from 180 degrees. Of course, we get a negative result, right? So this is going to be negative 125.9. But all is not lost, right? Because we can get to that point on the unit circle, right? So basically we're saying this angle, this other point on the unit circle, corresponds to a negative angle of 125.9. But to turn that into a positive angle, we simply need to add 360, and that'll find the value of that angle from a positive rotation coming around the other side. So if we add 360 to that, we get 234.1 as a second solution. So the two solutions for the second equation here, sine of x equals negative 0.18. The two solutions would be 234.1 degrees and 305.9 degrees. For the last equation to solve this last equation algebraically, we can do a little bit of factoring. We have 0 on the right-hand side. Cosine is a common factor on the left-hand side, so we can factor that out. This is the same as cosine x equals tangent x plus 3. So using the principle of zero products, that means that either cosine x equals 0 or tangent x plus 3 equals 0. The first value is kind of some nice points on the unit circle. Cosine equals 0 at 90 degrees and at 270 degrees. We can, of course, use the calculator to find values for that as well. If I take inverse cosine of 0, we get the 90 degree solution, and then just as we did before, I can take 360 minus 90 to find that second solution. For tangent, when tangent of x plus 3 equals 0, it means that tangent of x has to equal negative 3. So I can take inverse tangent of negative 3 and see what we end up with. We get a negative angle for that, negative 71.6. So the angle that we're talking about is down here, negative 71.6. To get an angle in our range, of course, we can add 360 to that to get a positive value. So this angle corresponds to the positive solution, 288.4 degrees. And then to get the other angle, well, that's going to, for tangent, that occurs on exactly the opposite side of the unit circle. And so we can get to that other side by either adding 180 degrees or subtracting 180 degrees. Well, for this angle, if I add a 180, I'll be outside of my range, so I can subtract 180 to get to the other side. So 288.4, if I subtract 180, we end up with 108.4. Let's check our work this time in a slightly different way. We can create a graph of the expression to see when in fact it equals 0. So we're interested in places where tangent x times cosine x plus 3 cosine x equals 0. And so looking at this graphically, if I type in that expression, tangent x times cosine x plus 3 cosine x, I'm interested in looking at places between 0 and 360. Right? We're looking for solutions on that interval. So before I look at the graph, I want to make sure I'm in the right mode. So we are still in degree mode. And then I want to go to my window and enter my limits for the x values to go from 0 to 360. Rather than counting up by 1 unit at a time, let's count by 30 degrees at a time. And then, because I'm really just interested in what's happening at the x-axis, we can maybe make the y values go from negative 4 to 4. Right, that'll give us a slightly closer up picture of the x-axis. So let's look at that graph and see what we end up with. So we can see our curve, it crosses the x-axis once, and then it crosses the x-axis a second time. But from our algebra work here, we found 4 solutions. We found 90 degrees, 270, We found 108.4 and 288.4. But from the graph we see only two solutions. And so to try to reconcile the difference there, let's think about what's going on. The solutions that we see, well, we're counting by 30, so these little tick marks, the little hash marks are at 30 degrees, so that's 30, 60. There's not a solution at 90. And then similarly, there's not a solution, this hash mark here would be 270. There's not a solution at 270. So the values that we see, they correspond, and we can use the trace key to see that. The values correspond to 108.4 is one of our solutions, and 288.4. So we can confirm that those two are solutions. Apart from some rounding error, we're seeing the expression equals essentially 0 there. But there aren't solutions at 90 and 270 degrees. So let's think about why there aren't. Well, the problem, recall that tangent of x equals sine of x over cosine of x. And these are the two places on the unit circle where cosine of x equals 0. So those two angles, they force us to divide by 0, and that's undefined. And so these are actually called extraneous solutions because they aren't actually solutions to the equation. And so the two solutions to the equation are the two that make tangent of x equal to -3, 108.4 degrees and 288.4 degrees. One last way to kind of look at our graph here and see this result, if we go to the zoom window options, zoom trig, when you're in degree mode, it'll spread things out from roughly -360 to 360, and so we'll get to see kind of two cycles of this graph. But what the zoom trig option does is it kind of makes the places where calculations happen sort of nice angles, and so it actually tries to calculate a solution for 90 degrees, and it sees that there isn't one, and there's a hole in the graph there because of that. And it tries to calculate a solution at 270, but there isn't one, and we can see the hole in the graph because of that. And so getting rid of the negative side of things, we can make the x minimum equal to 0, and we'll see this again. Yeah, so we see a problem at 90 degrees, and similarly we see the problem at 270. We see those holes in the graph, and so those are false solutions. They aren't actually solutions. That's just one of the many reasons why it's a great idea to check your work. Make sure that you didn't introduce false solutions through some algebra process, and make sure that the solutions that you find and declare to be solutions are correct ones. All right, well, thanks. I hope you enjoyed the video.